Detection of ADHD based on eye movements during natural viewing. ADHD is a prevalent disorder in children. It's characterized by inattention, hyperactivity, and impulsivity, which impair children's daily functioning at home or school. The current gold standard diagnosis requires expert assessments, which make the evaluation process very slow and costly. The SWAN rating scale is another commonly used screening tool. It's based on subjective self and parent reports. The final score obtained can reflect the severity of ADHD symptoms. However, this SWAN score is continuously distributed, and there's no clear cutoff for it. The ADHD and control groups are often not completely separated. This motivates us to develop more objective automatic screening tool. When people interact with their visual environment, like viewing an image, two events of eye movements, fixation and saccade, can be extracted from the raw eye tracking signal. They occur alternately and form a sequential scan path in a scene, from which we can infer an individual's brain function, attention, and cognitive states. Therefore, we are interested in exploring whether ADHD can be detected based on their eye movements in task-free viewing. For this, we develop a neuron sequence model, which takes as input the eye gaze and video. We use pre-trained saliency maps to highlight possible regions of interest in scenes and collect the map's predictions at every fixation location to generate a sequence of saliency values, which is merged with the sequence of fixation location and duration, and fed into a 1D convolutional neural network. Our model is trained in 2 steps. Recall that this SWAN score is correlated with ADHD detection. We therefore first pre-train the model on SWAN score regression. Besides, the model can be trained on a larger dataset to help solve the data scarcity problem. Subsequently, we fine-tune it on the ADHD classification task. We evaluate the models on the HBN dataset using cross-validation. We use the AUC metric and evaluate on 4 different videos. We showed that our model performs significantly above trans level in 3 out of 4 videos, marked with asterisk. For the best performance video found with fractals, the pre-training further improved the performance of model trained from scratch and outperforms the baselines.